Hello and welcome to this wonderful course of computer networks. And today we are going to discuss about DNS, one of the major and most important application at application layer. Its full form is a domain name system, and this particular system is used for uh, uh, mapping between IP address uh, and a name which you always used in a URL for browsing a web page from a particular web server. So the you the address of a particular uh, web server which you mention in your URL, that address needs to be converted into a IP address where your client will create a TCP connection and send a HTTP request for browsing a web page in the form of HTTP response at the client side. So most of the time you must have seen whenever you have to browse a web page from the web server, you go to web browser, you put in a URL in a URL field and try to browse a web page from a web server, and that URL initially got a host name followed by the path of that particular page which you need at your end. So basically domain name system is an application which is used to map between IP address and the name, because most of the time we being humans, we tend to remember names instead of numbers. And you must have seen in your life as well that you recognize your friend with his or her name instead of his or her Aadhaar card number or his or her driving license number. So most of the time, and the most important fact is you always call your friend with his or her alias names, not with their complete name. So it's a human behavior, human tendency to remember names instead of numbers. So that is why we have a system in our computer network architecture which is used for mapping between IP and name. So domain name system is a system where we have all the mappings, and that particular mapping which are residing inside a particular server, but that particular server is not in the form of centralized database. That particular server is like in the form of distributed database, which is implemented in hierarchy of many name servers. So we have uh, 13 name servers with the name A, B, C, D, E, F, G, H, I, J, K, L, M. So these are the names of our 13 name servers. Now, these are the services provided by domain name system, that host name to IP address translation, host aliasing means, as I told you, that it converts your complete canonical name into alias name, or alias name to the complete canonical name. As you must have seen that your friend, South Indian friend, has a very big name with his or her parents' name in between the good name and the surname. In the same way, but you call your friend with the alias name. In the same way, lot of servers has a very big name, big canonical names, but we always remember those web servers with the help of their alias names. So our DNS domain name system uh, provides that facility as well, that humans can remember those web servers with the alias names, that DNS convert those alias names into canonical name, and then through those canonical names, that DNS gets you the IP address over which you create the TCP connection or UDP connection for getting the response back. The third task of your domain name system is load distribution. As you can see, if all the clients will send request to a particular web server to get the web pages, then that particular server might get crashed because of multiple requests from the client side, which that particular server can't handle. So we have server farms with the same server farms in which we have multiple servers with the same IP address, and domain name system is the one which distributes the load of a particular server among n number of servers which are present in that particular server farm. So these are the tasks performed by your domain name system. And one of the question, that important question is, why not we have a centralized DNS server? If we would have a centralized DNS server, then what all are the shortcomings and disadvantages, like single point of failure? If we have a single DNS server through which all the clients, DNS clients which are present in this world, will send a request to convert the name into IP address, then it's going to be very difficult for a single centralized DNS server. And if that particular server gets failed or overwhelmed with the multiple requests from different users present or sending requests across the world to that particular server, then that particular server will get broke away. So it's called single point of failure. Then the second problem which might occur is traffic volume, and the third point is distant centralized database, which means for some of the client, that particular centralized server would be closer, and for some of the clients, for other clients, that server might be at a very distant position, where you will feel the delay in the response. And the fourth point is the maintenance part. If you keep your centralized DNS server in a maintenance stage, then during that period of time, that particular service is not be available for the clients. So these are some points because of which we do not have a centralized architecture for domain name system. So as you can see on the screen, that we have a hierarchy of domain name system servers, and we have three types of servers available, DNS servers available in this particular hierarchy. The first and the foremost DNS servers are called root DNS servers, which are also called name servers, and we have 13 name servers with the name A to M. And then at the second level of this hierarchy, we have authoritative servers in between these two tiers. Initially, we have root DNS servers, then we have top level domain servers, which are also called TLD servers, and at the third level of this hierarchy, we have authoritative servers. You can see the information about these commercial websites, basic information, or the mapping, actual mapping residing at these authoritative DNS servers of their specific companies, and the information about these servers are residing at the top level domain servers for commercial websites. In the same way, for .org, we have org organizational DNS server for keeping the information of these authoritative servers which are used for this particular .org purpose. In the same way, we have the top level edu DNS server, which keeps the information about all the educational websites or web servers which has the actual mapping. So information of these authoritative DNS servers are residing at the top level domain servers, and information about these top level domain servers are residing at the name servers or root servers. So this is the hierarchy of DNS servers which we have. And you can see that example is mentioned in this particular slide, that if a client wants IP address of this particular URL or this particular web server, which is www.amazon.com. So client queries about this particular web server, and client queries about the IP address for this particular against this particular name. Then client queries to a particular root server to find uh, com DNS servers, because this particular address is got commercial extension. So client will request to find the commercial domain name server for this particular address. So when request goes to this server will get you the request, get you the IP address of this particular domain name, sorry, top level domain server. Then client queries .com server to get the amazon.com DNS server. Then once you get the IP address of this particular server from this server, you request this server to get you the IP address of this particular server, where you get the actual mapping and you get the IP address. So once this server will get you the response of this particular server's IP address, then you have the IP address of the authoritative DNS server, which is keeping all the amazon.com commercial web servers IP addresses or their mappings. Then this particular server will reply with the particular amazon.com server's IP address. So this is the hierarchy. First you need to contact the root server, then root server will get you the address of top level domain server, which is having the address of authoritative server, which is having the actual mapping of this particular name which you are looking for. So here in the second step you can see client request .com DNS server to get the amazon.com DNS server. Then client queries amazon.com DNS server to get the IP address for www.amazon.com server. And these are the actual locations of 13 root DNS servers or name servers available across the world, which you can see as I told you a few minutes back, that these servers are named from A to M. You can see A, and you will find the last server with the name M. So these are the locations of 13 root DNS servers available across the world. Now, finally, we have two ways to retrieve the actual mapping of name against IP address. Those two ways are iterative and recursive. In iterative way, I'll explain you in this particular slide that how iterative way is used to retrieve the IP address of a particular web server. So as you can see, this is a requesting host, this is root DNS server, this is top level domain server, and this is the final authoritative server, which has the IP address of the requesting address in the URL. And one more thing which you will find in this particular diagram or in this iterative query is the local DNS server. So this local DNS server is not the part of the DNS hierarchy of servers, which includes root, TLD, and authoritative. This local DNS server is not the part of these DNS hierarchy, but this DNS server is acting as a proxy server which keeps the information or which keeps one copy of information which can be used by the other requesting host, and to save the end-to-end delay and bandwidth of this particular scenario, this particular local DNS server keeps one copy and satisfy other requesting host by itself. So initially when this particular local DNS server doesn't have the information about this uh, requesting address. This particular client needs the IP address of this particular web server, where this particular client can create a TCP connection or UDP connection to send some information and retrieve some information. So initially this particular client will send a request to local DNS server, and this local DNS server, in the iterative query format, this local DNS server will contact the root DNS server. Then root DNS server will respond back to this local DNS server with the IP address of this top level domain server. Then this particular local DNS server, on behalf of this particular client, sends a request to this top level domain server, and this top level domain server uh, respond back with the IP address of this authoritative DNS server. And finally this local DNS server, on the behalf of this particular client, sends a request for the IP address of this particular web server, and this particular authoritative DNS server has the actual mapping of that IP address, and this particular authoritative DNS server respond back with the IP address of this particular web server which this particular client is looking for, and finally revert back with the IP address to the client, and keeps one copy of this mapping with itself. And whenever any other client requires the IP address of the same web server, in that case that particular request is satisfied by the local DNS server itself. So we can save the end-to-end delay time, end-to-end delay, and we can save the bandwidth as well. In the other way of DNS for the query is recursive approach, and in this particular recursive approach, you can see this requesting client is sending a request to local DNS server, and this local DNS server uh, on the behalf of this client sending a request to the root DNS server, which is nearer to this particular local DNS server. Then instead of replying the IP address of this TLD server to the local DNS server back on the behalf of this particular client, this root DNS server calls the top level domain server by its own. You can see first step, second step, and the third step. Then this particular top level domain server, on the behalf of this particular client, for a query for this particular web server, it sends a request to the authoritative server which has the actual mapping for this particular web server's name, and it replies that particular IP address to this top level domain server. Then this top level domain server replies back to the root DNS server, and then this root DNS server replies back the IP address to this local DNS server, and this local DNS server replies back that particular IP address to this requesting host. Then this particular requesting host uses that IP address for creating a TCP connection with the server, with the required server. So that is how these two query formats are there in DNS. The first one is iterative and the second one is recursive approach. Okay, now in this particular slide you can see DNS records. DNS distributed database storing the information in the form of resource records, and you can see the format of this particular resource record, which is uh, formed with the help of four tuples. The first tuple name is name, the second is its value, then the type of resource record, and the TTL field, which stands for time to live, which means how long this particular resource record is going to alive in the network. So these three fields are very important in the resource record. The first one is the name, which is the question actually, and second one is the value, which is the answer of this particular question, and the third one is the type of resource record. So here on the screen you can see four types of resource records are there. The first type is type A, the second type is type NS, and then the third type is CNAME, and then the fourth type is MX. So initially we have type A, and in which if this value is A, that means this resource record is having the host name in the name field and IP address of that particular host name in the value field. So this is the main and actual resource record which gets the actual information of IP address of a particular host name. In the same way, the second type of resource record which are residing inside the distributed database is NS, which stands for name server, and in this particular type the name is got the domain, for example food.com. So it contains the domain name, and against that we have a value of this particular domain name. In that particular value we have the host name of authoritative name server for this domain, which I mean to say is for this particular commercial food.com commercial web servers, in the value of this against this name would be the host name of authoritative DNS servers which are having the actual mapping of IP address against the host names. So this is the second stage, and this is the final stage. In the same way, we have third type of resource record with the name CNAME, which stands for canonical name, and this particular resource record is used for getting the actual canonical name from the alias name, because in the name field you find the alias name for some uh, particular server, or it is also called the real name of that particular web server, which is www.ibm.com, which is actually server east.backup2.ibm.com. So this is the canonical name of a particular web server, and this is the alias name of a particular web server. So most of the time humans are tend to remember short names, alias names. Then humans only remember a short name of a particular web server. Then DNS has to convert that particular alias or short name into canonical name first of all, and then we can get the IP address of that canonical name from the authoritative DNS server, because actual in the actual mapping we have canonical names with the IP addresses. So this particular type C name is used for converting alias into canonical name, and this particular resource record is used for getting the canonical name from the alias name. And in the same way, type 4, which is MX, which is used for mail servers. This particular CNAME type is used for converting the alias name of web servers into canonical names of web servers, and this MX type is used for converting the alias name or getting the canonical name of mail servers from their alias names. So type MX is got the information of um, mail servers and their canonical names. So these are the four types of resource records available in domain name system: type A, type NS, type CNAME, and type MX, which are used for which are residing inside the distributed database and which are used for converting the host name into IP address or for getting that particular mapping. So that is done for domain name system. I hope you understand this lecture. See you in the next lecture. Thank you.